Welcome to part 4 of Earth's dimension and navigation. In this section, we'll be going over the relationship between Polaris and latitude. So how can latitude be determined without technology? Okay, without your GPSs, or even possibly without maps. Polaris, our North Star, is used to determine latitude in the Northern Hemisphere. Okay, if you've never seen Polaris, Polaris is at the end of the handle of the Little Dipper. Okay, and in this session, we're going to talk about how do we find the Little Dipper and the star Polaris. Because Polaris is located directly above the north end of the Earth's axis of rotation, which is the North Pole, it is the only star that never appears to move as Earth spins. So in the bottom here, we have a simulation or a model of the Earth. We have labeled our north and our south. Okay, the North Pole, right above it is Polaris. Now, if we're looking at it, and if I was standing on the North Pole, I might have to look straight up to see it. Now, if I was located on the equator, it might be at a lower angle above the horizon. Okay, let's just give you guys a couple seconds to see if you can find it. And if you don't know how to find it, that's okay. This was Polaris. Okay, so if you're looking at Polaris, you're facing due north, which means directly north. So if this is our vision of Polaris, we are looking due north. So the altitude of Polaris above the northern horizon is equal to the observer's latitude. Okay, what that means is when we're looking at the angle, or the angle of the altitude, is how far it is above the horizon. Okay, it's just going to be a degree of measurement. The observer is using a telescope to look at Polaris. That angle is how much tilted the telescope is off of the horizon. Okay, the lowest point that's visible on the ground. The measurement of altitude has no direction. Okay, just a degree sign. And latitude must have a direction except at the equator. Get a little more practice with that. So if I was at the North Pole, Polaris is 90 degrees above the horizon. So in order to look at the North Star or the Polaris, I'd have to look directly up. Okay, another word for that would be zenith. Okay, and we'll see that in the next slide. So here's Polaris in the picture on the bottom left-hand side of your screen, and it is at 90 degrees. And you're also at 90 degrees north latitude. Now, if I was at New York City, I'm at 41 degrees north latitude. Polaris will be 41 degrees above the horizon. Do you guys see the trend here? Okay, in the northern hemisphere, your latitude will be equal to the degrees that Polaris is above the horizon. The girl is standing here. Okay, she's standing on Earth, and she looks at Polaris. Okay, that's the star on the left-hand side. She sees that it's 45 degrees above the horizon. That would mean that she's at 45 degrees north latitude. That term zenith I described before, it just means directly overhead. Okay, it has nothing to do with your latitude. So checkpoint. The diagram below shows a student in New York State observing Polaris. You see Polaris is 42 degrees above the horizon. Okay, and then it's 48 degrees from Polaris to the zenith. So that's a total of 90 degrees. What is the latitude of the student? Make sure you use the direction. Now, name one city in New York State where the student may be located. In order to do this, we need to use our Earth Science Reference Tables, page 3. If she was at 42 degrees north latitude, we would see it would have to be along this line. Now, if you go along that line, there are several localities, such as Jamestown, Elmira, Binghamton, Slide Mountain, Kingston, that could be possible answers for that question. How can you locate Polaris in the night sky? So the two constellations we see on the screen are the Big Dipper and Little Dipper. And then below we see the horizon. So the first thing you're going to do is locate the Big Dipper in the night sky. This constellation is easily recognizable in the night sky and looks like a large spoon or a ladle. You're going to locate the two stars at the end of the cup of the Big Dipper. Okay, these pointer stars, which we call them, are Dubhe and Merak. You're going to draw an arrow through these two pointer stars toward the Little Dipper. Okay, and I'll show you that in a second. The star in the Little Dipper at the end of the handle your arrow points to is Polaris. So we're going to draw a straight line through Dubhe and Merak, those two pointer stars that are on the end of the cup. Okay, and we're going to line up directly as we draw a straight line and arrow to Polaris. Okay, so that's how you can find Polaris using the Big Dipper. And then if you see Polaris there and you're pointing in that direction, that would be directly north. Okay, here's another image of the same thing we're explaining. It's going through Dubhe and Merak, and a straight line with an arrow would point to Polaris. Another checkpoint. The diagram below shows some constellations in the night sky, as viewed from a group of students in Messina, New York. Now, it says on the diagram, circle Polaris. I'm going to do that for you guys. So in order to do that, we have our Big Dipper to the left-hand side there. We're going to use the two pointer stars that are at the end of the cup, and we're going to line them up and draw a straight arrow until we get to the Little Dipper. The star at the end of the handle is Polaris. Now for B, in which compass direction were the students facing if they saw Polaris? Okay, remember, they're in Messina, New York. Okay, so if they're in Messina, New York, what was the altitude of Polaris as viewed by these students? So we have to go back to our map. I'll give you guys a couple of seconds to find Messina, New York before I show it to you, and then I'll let you answer the question. Now, Messina, New York is located way up north of the Adirondacks in the Champlain Lowlands. You can see it's located in the top left, right where it says, right under the red line here. "45 degrees would be the angle above the horizon, just like the line of latitude that Messina goes through."